Hey, there we are.
Hey.
How's everybody doing, Julian? How's it going, Julian?
I'm very good. That's an awesomely dramatic entrance. I like the music.
Did you like
Well
that?
done.
I know. Well, I don't. I think Chris kind of did like, kind of gave you that like the first time he heard it, but it's dramatic. I like it. So actually, he was cool about it. He liked it. So
I can see you walking onto the stage with the ring in the middle with your
that's right,
Eric Rocky style.
That's absolutely right. Well, hey, welcome to Serverless at reInvent number 5. You want to help me out there, buddy?
Yeah.
All right. Okay, there we are. That'll work. Yeah, that'll work. You can't even find your camera. Man, we're in our second week of reInvent. How you doing? Second week of reInvent. In fact, this is the last Thursday of the second week, and a lot's been going on. And we're gonna cover a lot. We're gonna cover some stuff you may have seen already. You may not have had it in the time zone, things like that. But we're probably gonna go a little deeper into some stuff. So I'm excited to get started. Julian, what are you excited about?
I'm excited about reInvent. It's been obviously different this year, in a challenging year, in a different kind of year, but I'm loving that reInvent is able to be virtual, to be global, free, so literally anybody can participate.
That's right.
And so yeah, we're super happy. It makes it just so nice that we can get people from all kind of all time zones and all kind of things. And I think we're also, and people are working out how to do reInvent properly. And yeah, I hope people are really enjoying it. Yeah, this is live. Obviously, there are going to be loads of mistakes. There are going to be bad dad jokes from Eric.
I am a bad dad, and I tell you.
And most importantly, questions. So literally, we're live. We're here to answer your questions. If I don't know, Eric certainly won't know. And if Eric doesn't know, we've got most of the rest of our team in the background. They got fingers on keyboards, poised to answer your burning questions about Diet Pepper or whatever it is, Dr. Diet Pepper.
Exactly. It's Diet Dr. Pepper, and you need to stop talking. If you say Diet Pepper again, I will tackle you. I'll fly to London and tackle you. So, no, yeah, you're absolutely right. I've seen Rob in there already. I've seen James in there already, and we've got some folks watching. So let's jump in. You got the deck, right?
Absolutely. Let's get the deck going. So hello. Look at that. So. That's the two of us. Eric, who the hell are you?
I am this guy right here. That's what I look like. In case you can't see me over here, it doesn't get any better. I've used that joke multiple times. That also doesn't get any better. So there you go. I am a senior developer advocate at Serverless. I've been here for 2 years now. October was 2 years for me. Having a blast. I love Serverless. I am a father of 5. That's not a typo. I am a 2-pizza expert because I love pizza, and I am the pizza aficionado. There is no pineapple on pizza, and I'm just going to leave it there. And then I'm a musician. I'm a drummer. I went to school to be a drummer. It turns out I'm fairly average, so I do this instead, and I love this. I have been an AWS evangelist in the past. I've been a senior software architect or developer of some sort or another, or designer since 1995. So I'm an old guy. So, Julian, tell them about you.
Like it. I, to be honest, I'm not as old as Eric because I'm certainly not as good looking, but I'm fast approaching. We're not going to do a guess the age kind of thing because that would be embarrassing.
That's a wig. He's wearing a wig.
We're the 2 oldest in the team, actually.
We are. Yeah. We're old guys.
Wise, I would say. Well, yeah. Hi, I'm Julian. I'm literally on the same team as Eric. We have fun every single day playing with servers and building serverless on top of servers. So yeah, I come from a different background. I literally have worked on the customer side as an infrastructure architect and manager and designer and all that kind of thing. And that's what attracted me to serverless is all that infrastructure stuff. It's just so nice to be able to abstract some of that away. And serverless is just absolutely awesome. So yeah, I've worked in enterprises, in finance companies and some startups. Yeah, originally from Cape Town, now live in London. So yeah, super cool to be here. Honestly, living the best dream job in the world.
That's right. My accent is not near as cool as Julian's, but I do love it. He has a really sweet accent. So why are we here today? All right.
Serverless at reInvent. I'm just
Serverless at reInvent. Yeah, that's what we're throwing out. So we're gonna cover some of the things that have been released so far, and then we've got some demos, and then we're gonna talk about. There's still, reInvent has been a week and 3 days now. So again, we're on that third one, but there's still more to come. There's still, I believe, 2 keynotes, and just finishing this morning was Peter DeSanto's keynote. If you missed that, there was some really cool stuff going on there. I encourage you to go back and watch that. That should be released on, I believe, this Friday, but we'll need to verify. But yeah, that should be out to watch.
Hey, definitely. We'll have more sort of looking ahead at reInvent a little bit later in this hour. But yeah, the Peter DeSantis keynote, I'm an infrastructure geek. So yeah, just super interesting, because one of the things we talk a lot about at AWS, well, people talk about AWS, is all the products and all the services and all the features that we do. And I mean, we're going to talk about some of them now, but but actually the really cool thing, a really cool thing is all how we operationalize all of this. And this runs on unbelievable global network. Peter went into all availability zones, regions, the servers, the Mac servers that we've got running now, talking about the sustainability, which is a super nice thing to go on at the end. What he was talking about UPSs, like all the innovation that AWS is about about UPSs, like, whoa.
Yeah.
So yeah, have a look at that, because it really gives you an appreciation of the massive scale of AWS. And yeah, just also made you think about how you build your own stuff.
Yeah. That's the peek behind the curtains that a lot of people don't get, is to hear people talk about that. And it's really interesting. So yeah, I agree.
Yeah, just one thing I'm picking up from the question is a keynote, which is not a keynote. There is one more keynote from Werner Vogels, but the second keynote, we calling it, is David Richardson. And because he's the VP of Serverless, he's our boss's boss. To us, it's a keynote. And to all serverless people, it's a keynote. So it may not be a keynote session but it's called the leadership session to find it. But yeah, that literally is going to wrap up reInvent in terms of serverless. So yeah.
Yeah, we work with some in serverless, well, in all of AWS, but we work with some really smart people, and David Richardson is one of them. And hear what he has to say, not only the tech, but the value and the business and the leadership in it. Really important, and I encourage you to take a look at that. All right, let's talk about some of the releases. If you haven't heard of some of these, you might have been in a cave, but we're going to make sure you've heard of them. So let's jump out, and we'll kind of buzz through these, because Julian and I both have some demos we want to show you.
Yeah, absolutely. So, Eric, what does this mean?
1 millisecond billing. This is huge, and it's already, you have to do nothing. It's already active. So 1 millisecond billing, and in my demo, I'm actually going to show you this kind of slick. But it used to be that we had a granularity of 100 milliseconds for billing. That's dropped to 1 millisecond. And this becomes really huge if you're running, short-lived asynchronous, synchronous calls that your Lambda functions are backing. A lot of the when I used to consult and work with companies, a lot of what I helped them build were API inputs. That's I'm the API guy, and I worked with that a lot. And Lambda's been the API or the Lambda functions are the back of the APIs, and a lot of those are very quick. So you have 2, 3, 5, 10 millisecond Lambda functions, but you were paying for a full 100 milliseconds of it. Well, we've now dropped that down. If you have 2, 3, or 5 millisecond Lambda invocations, that's what you'll pay, is that. So 1 millisecond granularity, no action needed, has already gone into place. So really excited about that.
Save money with serverless from December. I mean, what can't go wrong? Yeah, just the one other thing is, we all talk about the subs 100 millisecond billing, but also if you had a function that was 101 milliseconds, previously you were billed for 200 milliseconds, and that's now just 101 milliseconds.
That's right.
So yeah, it's not just the super fast ones, but it literally a whole kind of way. So yeah, I mean, you can't get more efficient than that, than 1 millisecond billing. Go and save your money.
Yeah, and it really, and here's the challenge to you in the audience. When you look at those functions, is how can you optimize them? What are you doing in there that you don't need to do? Are you doing some retry logic that could be handled at a queuing or a messaging service or something like that? Start looking at reducing that. Now, it's all about less code in a lot of ways, and we approach our design of our services in helping you do that. So I challenge you with that.
Yeah, because definitely to pick up on that, before if your function was running less than 100 milliseconds, from a cost perspective, it wasn't worth optimizing anymore. But now it really is worth optimizing it. So things like if you've got SDKs inside your Lambda functions and Python, Node, Java, whatever SDKs, maybe you don't need all the SDK, or you just need a small portion. Of that. So yeah, slimming down your functions, make it faster, going to be cheaper for you.
Yep. All right.
Yeah,
So,
and call out to James. James has written an excellent blog post on a Cloud Guru, and that's also got some of the tips we've been talking about: TCP, reusing TCP connections, and a whole bunch of other stuff, and the awesome AWS Power Tuning tool. So you don't have to figure this out yourself. You can get some help. So yeah, this is a really good blog post to look at, all about some of the cool things and tricks and tips you can do for one Silicon billing.
It's late night for Julian.
It feels just like we've been in Vegas for 2 weeks. We haven't.
The only difference is I haven't smoked 17 packs a day of cigarettes. I don't smoke, but we all know what that's like, walking through the casinos. But yeah, it does. It's been crazy. So couple this. Julian, I'll let you IDM on the last one. Go for it.
Yeah, sure. You can talk about faster stuff. I'll talk about bigger stuff.
That's right.
Yeah. This is also just such a cool thing. And basically, bigger, better, faster, more is the story of Lambda over 6 years. And yeah, larger Lambda functions from up to 2 dimensions, 10 gigabytes in memory, and 6 corresponding vCPUs. And so, yeah, you need more oomph in your Lambda function, just dial it up. Remember, Lambda functions have a single knob for performance, and that's based on memory. You add more memory, you automatically get allocated some more cores. So there's some great use cases for this. Obviously, the big sort of batch processing, media processing, ETL, analytics, all these kind of things. That's obvious, but obviously your application needs to be multi-threaded or your function needs to be multi-threaded to take advantage of this. So that's something obviously to bear in mind. But an interesting thing I've been thinking of is, well, hang on. I used to be able to, maybe I had a CPU intensive or maybe even memory intensive process, and I couldn't run it in a Lambda function because it was running 30 minutes, maybe 44 minutes. Well, hang on. If I was running only up to 3 gig of memory, which was the previous one, which was only 2 cores, I can now treble the throughput potentially of that Lambda function. And so something that was running, 30, 40, 44 minutes, which you couldn't run on Lambda before, now you can all of a sudden run this on Lambda. And so, yeah, it brings up a whole new possibilities of using Lambda with all that more oomph.
Yeah, we've seen a lot of in the Twitterverse. I've seen a lot of conversation and testing around calling it multi-threading. So splitting out to taking these large jobs, splitting it across several large functions, and being able to go serverless when before they couldn't. But I would also talk about the smaller ones. A lot of times, often we equate less memory costs me less, no matter what. But we've had quite a few tests that we've been talking about for a couple of years now, and especially with the 1 millisecond coming in this year, where just a little more memory and gives you that extra core, you can do a job a lot faster, and it might be the same amount of money or even a little less by getting it done faster and paying for less time on those in memory. So yeah,
absolutely. So dialing up that memory makes things run faster, and using that AWS Power Tuning tool will help to work that out. As I said, you don't have to do it yourself. As a question has come in from ForceAware, thank you. Is it true network I/O is also increased with memory allocation? Yes, that is correct. So network I/O and storage I/O is increased with the more memory you add. So one dial, you get more of all the other things.
All right, so we had something here. I'm just going to read this. I watched Rob's session and learned about leading keys for DynamoDB. Any examples on how to use this with SAM? So probably not today, but I do it's on pause right now, but I do a sessions with SAM in setting that up, and that's something I'll add to my sessions with SAM list. And Rob, maybe you can expound on that a little bit if you want to. So, all right, next. A biggie. They're all biggie. But this one's been a lot of fun to hear people talk about. And if you're all right, Julian, I'll jump in on this. Or actually, I'll let you do this, and I'll take the next slide.
Let me check. What's the next slide then? Eric knows.
Yes.
Well, yeah, AWS Lambda container image support, and this is actually a really super interesting release, and may really help you build your Lambda functions. Now, I've mentioned before and other kind of things, containers is a big word, and it means a lot of different things to different people and multiple things. And containers is all about a runtime. So, using the Docker APIs to actually run a container, to be able to have, to containerize something means to split it into microservices. Using containers is a whole bunch of different kind of tools. So they're different kind of things. Containers is also an isolation mechanism. So, that's what people talk about containers. So I want to be clear when we're talking about this containers is you can now build your Lambda functions from a container image as defined in a Docker file. So this isn't Lambda running Docker. This isn't running arbitrary containers on Lambda, although it may help you with this. But if you're a developer who's used to building Docker containers and who's used to using a Docker file and all the cool kind of stuff in there, this just helps you use the same tooling to now be able to build Lambda functions. And maybe that's going to help you to put this into a CI/CD pipeline, or to have a better workflow on your laptop, or to be able to, pass images around your company, or to be able to share images publicly. And so this really is a way that we can connect more closely with you as a builder, as a developer, so you can more easily, in the tools that you use, now consume Lambda. Lambda functions before were actually zip files. They were stored in S3. So yeah, that was super easy. That functionality does not go away. 100%. That is actually the simplest way to consume and use Lambda. So if you're doing that, continue, have great fun. All the rest of Lambda works exactly the same with that. This is just another way to build your functions, and is really targeted for people who love Docker files, Docker images, and want to take advantage of that. With one extra little bit of caveat is that, no, actually not a caveat, is an extra thing is Lambda container images can be up to 10 gig in size. Ta-da! So zip functions could be up to 250 meg, and Lambda container image supports can now be up to 10 gig, which really blows the world open in terms of, machine learning, as it says there, data analytics, large dependencies, all the kind of bin packing and, crafty kind of stuff people had to do to just keep those Lambda functions under 250 meg. This makes that all kind of different, and allows you up to 10 gig.
All right, so I'm going to preempt the question that we almost always get when we talk about this. Are you ready for it? What does that, if I have a 10 gigabyte container image as a backend is for my Lambda function, that's how I package my Lambda function, what does that do to my cold start, Julian?
Absolutely. That's the big panic question of people wondering. What we've done with a container image support is we've basically re-architected how function code gets to Lambda. And so we were going to go through in the demos later, and Eric's next slide is going to talk about this, is the development workflow. But what this basically means is you then, when you build a Lambda function as a container image, you store it in a repository. You then build the function from that image in the repository. But what we do in the background is we optimize that image. And part of that optimizing that image is we actually cache parts of that image as close to the Lambda function as it's going to run, where it's actually going to execute. So if you think you're going to be building a Lambda function and you are going to use the Python runtime or the Node runtime, or even a custom runtime from something like Alpine Linux or Ubuntu or whatever, maybe you're going to layer some SDKs on that. Maybe you're going to pull in some other kind of binaries. If you live in the Docker world and you understand the Docker files, those are all little layers that are managed within the actual Docker image. All those individual layers, we cache close to where the function is going to run. So cold starts really should not be any worse or any different from your zip function archives. And that cache does need to be pre-warned, but that's something we do on the function create. And the cool thing about this is because these Docker layers are shared between many functions, think of something like the Python runtime, that's going to be, I don't know, thousands and thousands, heck, maybe millions of functions out there using Python. That's going to be very optimally cached close to the function. Your startup time is going to be really, really good.
Yep. All right. So here's the process. And I guess and the next, I'm taking these 2 slides, Julian, I'm doing it. So when you're building a Docker image to support or for a container image, it's early in the morning and I can't talk either, Julian. When you're building a container image for a Lambda function, you really what you're going to do, and this is kind of a, hey, I had the developer do it, but this also works in CI/CD process as well. But you have your container image. You're going to build your container image on your desktop or your IDE or in your CI/CD process. And this is where we talk about, hey, we're just using these standard container tooling that is already used worldwide for different container workloads. So this enables you to use those same tooling to produce this Docker image, right, or this container image. Now it's going to be based, and this goes back to what Julian was saying. I can't just take some arbitrary container, just throw it in Lambda, and expect it to run. It does need to be based on one of the base images that we provide, or you can build your own. And we have instructions in that to do the runtime emulator and different things like that. So you'll be able to build that out.
The reason for that is that other containers, you often expose a port and a socket that something needs to connect into. And you run Nginx in the container or that kind of thing. With Lambda, you don't really need to do that at all. In fact, you don't do that at all. And so this container model, that little bit of software that Eric's just talked about, is the way that your container can communicate with Lambda. That's just the functionality. Something needs to pass messages to and from the Lambda service, and that's what that does, and you package it in your container.
So real quick, I'm going to call out, we are being trolled a little bit by Mr. A.M. Grobelny, Dr. G, and he asked, Eric, what will happen if I run the Lambda container inside Lambda? That is tantamount to crossing the streams. So I'm just throwing that out there, and I think you should be the first to try that. So yeah, it's functions all the way down. It's Inception. That's right. Lambception, as Rob Sutter has
said.
Put it here. Yeah. So, all right. So we're going to create that local image. Then we're going to push it to Amazon Elastic Container Registry. So, and I think you saw we now have ECR public, which there's the public and there's the public gallery that you can store those. So really helpful if you're needing to do a lot of pushes and pulls from ECR. And then what's going to happen is when we actually create or update a function, we're going to pull that image from the ECR, we're going to optimize the image, and we're going to deploy the image to Lambda to be ready for invoke. And then what happens is your Lambda function becomes active and it's ready for invoke. So there's a process there, and you can use a lot. Again, you can do this in CI/CD. You can do this from your developer setup. So jump to the next one there, if you would. Something we're going to show, and I have a blog coming out on this. It'll come out early next week. SAM will do a lot of this for you. It'll actually, the SAM package or SAM deploy options will handle creating the container image, pushing it to Amazon Elastic Container Registry, and creating the function and bringing it all the way to that active status ready for invocation. So, and I talk a lot about that. I'll show a little bit about that in our demo. And I think we probably want to start getting there. What do you think?
Absolutely.
Yeah. Okay.
My demo is just actually also going to be combining the container image format with Lambda extensions. So just quickly, Lambda extensions is a new way to integrate Lambda with your existing tooling, and an extension runs as a separate process with your Lambda function, and that can grab info from the Lambda service, things like telemetry or logs or that kind of data.
Yeah.
You can build your own extensions using the API or use the logs API to grab logs from Lambda. That was literally the elevator pitch. Only via 2 floors, I think. So yeah, there are 3 blog posts over there which go into all of that, but it's just to frame what I'm talking about when we talk about extensions.
Hey, I'm going to jump in and answer this question real quick. We have, what about cold start times for containers versus Java versus Node versus Golang? Well, in this question, we're kind of comparing apples to oranges a little bit in that we're saying containers versus Java. So let's back up in a second. So we have containers versus or containers and or zip packaging, right? And those are going to be the same thing. So what we're saying is a container, regardless of the language, irregardlessly, I always get that word wrong. Regardless of the language, if either container or zip backed Lambda functions should have very minimal cold start or equal. They should be comparable. Right now, when we talk about Java versus Node versus Golang, yeah, there are some languages that, like Java, we do some reflection in Java that can take a little longer on the cold start. However, there's an amazing presentation from Stefano Bugliani last year where he talks about really trimming down and a lot of tricks and tips you can do with Java if you're using Java in Lambda functions. We all have our favorites. I'm a Node guy. Rob's a Golang guy, and there's some different pluses and minuses in those, but you don't want to compare containers versus Java, but containers and or zip, and then your different languages have different nuances about it. So
yeah, think of containers as the packaging format, and once your code gets there and then starts running on Lambda, then you're talking about the different language cold starts. And yeah, there was just a question to do. I missed that. Is there a better way of testing container-based Lambda functions locally using Docker Run? yes, you can use Docker run to locally test your Lambda applications, and that works. That works super well. So yeah, let me just. I'm going to quickly go through some of this over here, because obviously codependencies. We are a codependent couple, I think. Eric, I got that confused.
We are. Absolutely.
Code dependencies. Lambda layers has been one of the ways that you can keep shared libraries or dependencies within your Lambda functions, and extensions were actually delivered via Lambda layers and are delivered via Lambda layers for zip archive functions. But Lambda layers are not directly supported in container images, and that's not because it doesn't work or it's something we're working at, because you don't actually need to, because when you build a container image, you've got far more control of exactly what goes into that container image. Just a little sidebar, that does also mean that you are a bit more responsible for updating and maintaining those images. When you do create a container image, it is immutable. And so with the zip archive function, when it runs, every time it runs, we may update a CDK in the background, or some Python or Node or Java runtime, continually updating. That's cool for most people. Some people go, that means that can break my code, so I want to be able to have an immutable artifact. Container images are immutable artifacts. Good benefit for you, but you do need to take on a bit of additional work to make sure that regularly you're updating those files. Anyway, back off the sidebar. So that means that you've got this ultimate control into creating your container images, and layers and extensions are actually just files copied into file paths, stuff copied into the opt directory. There's nothing fancy from sort of process perspective or anything like kind of that. And basically it means you can use a Docker file just to copy the layer functionality into your container images. And there are a few different ways of doing that. If you looked at the zip archive function, this is how you would add a layer via the CLI, just dash layers, and the R is 2 layers. That was the way with a zip function archive. What you can do with a container image is you could basically, the easiest way with a container image is if the publisher of that image has a container image version. And there are 2 ways of doing this. I've only actually showed the one here where you've got a from command, and that is just adding, in a normal Docker file, you build your image of all of these different layers. And this is just saying, you know what, grab from my shared library layer and copy to the opt directory. It's using a thing called multi-stage build. So it means afterwards you do some stuff to tidy up your build and make that good. There's also another way to do it that you can just add literally a zip archive that's sitting on the internet. So in a Docker file, you can just use the add command and do that. And basically that's a really good way. The simplest way is to forget about Lambda layers, just use the container image version of a Lambda layer. The next way you can do it is, if there isn't one, well, what can you do is you can copy the contents of an existing Lambda layer into a container image. Now, 2 ways of thinking about Lambda layers. Sometimes you may have the source code for the Lambda layer, but often you don't have the source code for a Lambda layer. Someone else has published an SDK or something, and you don't have the source for that immediately. But what you can do is you can literally build a Docker file and grab that source layer, which pulls it from S3, and copy those files into your container image. Now, in the blue, it's important to understand there's some authentication over here. On the blog post at the top right, I've written about this, and that's actually going to be updated shortly with just some more clarifying information. But the way you build a Docker file is you also need to authenticate with S3. And unfortunately, the way the Docker file works is you need to pass up some keys to AWS to be able to authenticate with authenticate with Lambda get layer to then get that layer code. So I'm just calling it out there. There are also some security things to think about that. And what you then do there is you just basically unzip that, and then we're using the multi-stage build, so you can see from scratch what then happens. You've used your SDK, you've used your keys. And then from scratch means it chucks everything away from before in the Docker file, and you have a clean Docker file image that you ultimately have, which doesn't have any credentials in it. So that's something, go to the blog post, and that's going to be updated for that. The other way is, if you do have the source code for your layer, is to just build that into your function image. So you can either build it to your function image or create an image layer just for your extension. So this is just, I've got my layer code, I've got my extension code. Why don't I just create my own curated image layer for a Docker file? And this is how you would create that. You just start up with Python, for example, and that's just so you've got the pip command, install your requirements. If you were using Node, you would do node npm install, do all of that, and then you copy those files back into the container image, and off you go. Then you would build tag and push that extension image layer, as Eric mentioned, up into ECR, and then you would build a function which references that extension image layer in your Docker file. So again, this is all just copying files in a number of different ways.
Did you get all that? Everybody good?
I know. I'm trying to get a demo, and I'm like, whew.
I know you're going to demo this, right?
Absolutely.
I'm like, whoa. Yeah. So I think the bottom line is, the first time you pull it, if you can, just my opinion, I would create a Docker image. As soon as you can get it to your own Docker image, I think that makes sense. And that makes a lot of. So you might do the manual work of pulling a Lambda an extension or a layer and creating a Docker image, or you can have it automated as well. So I'm sorry, you're trying to get to the demo. I'm going to zip it.
No, not absolutely. This is all good and important stuff. We've had a lot of questions since the announcement of like, oh, I use Lambda layers, I use extensions. What do I do? So yeah, look at the blog post. This is a whole bunch of different. Ways forward. And ultimately, to finish off what I was saying is you basically build a function and you've copied the layer files into your function and you're off to the races. Let me just see, one of the questions is, if an underlying layer gets updated, we have to rebuild the Docker container to publish to Lambda. Yes, that is correct. And that's not just for a layer, that is anything that you put in your container image. So when you create your container image, upload it to ECR, it is immutable. So if you update an SDK or the version of Python or anything, you are going to need to manage the contents of that container image.
I think you posted one of the QR codes, but I just posted as well. If you look for the blog he's talking about that really talks to this at length, I just posted Julian's excellent blog on this. So,
thank you. Another question was, I thought the Lambda, where did it go? From Whitelol, I thought the Lambda runtime was just listening to a port. That is how custom runtimes are implemented. Yes and no. So Lambda runtime, the Lambda service is listening on is an API call. So you always invoke Lambda via an API call to the Lambda service. Within your Lambda function, you don't need to listen for a port or need to listen for a socket or something like that. Go does work like that, but let's keep that slightly differently because it still follows within the event-driven model of Lambda. Custom runtimes do work with the container images, and there's also basically another little another piece of code that goes in there, which is called the runtime interface client, and that your code talks to the runtime interface client, and that's what then talks to the Lambda service. That you install manually if you're building a custom runtime image. If you're using the AWS created images for all our supported languages, from Rust to Go to Rust, Python, Node, all of that kind of thing, that's built into that. So hopefully that makes sense, that if you use our custom, if you use our AWS provided runtimes, that interface client is built there. You don't have to do anything more. If you're building a custom runtime, you need to add that, and it's just another layer in your file.
Yeah, that question was part of a longer conversation that's been going on, and Rob's jumping on it as well. So
cool.
Good job.
So Eric, are you demoing first or me?
No, go for it. We've already kind of talked about what you're demoing, unless you're saying, "Hey, Eric, why don't you demo first?" Then
no, pressure's on.
Okay.
Pressure's on.
Yeah, pressure's on.
So basically, I have got. I do have it. In fact, I do have a demo which is going to talk about extensions, and I think I just did actually have another slide which went into it properly. No, I didn't. Obviously, didn't stick that in the deck because that would have been clever. So basically, I've got a Lambda extension over here which talks to AWS App Config. If you don't know what App Config is another configuration management service from AWS. You may be scratching your head thinking, hang on, we've got parameter store, we've got secrets manager. What is this all about? Well, App Config has a slightly additional approach in what they do, is that you can safely roll out configuration changes to EC2 containers, Lambda, anything in a coordinated way. So if you think, for example, in parameter store, you store a an environment variable or any parameter that's going to do something. With parameter store, you don't have a way to safely test the rollout of that to any of your systems. App config has a way that you can do a rolling stage deployment of any config. You can use Lambda functions or other ways to test that rollout. And so it's a really nice, safe way to roll out configuration changes. They've implemented, in order to talk to app config, normally in a Lambda function, you have the SDK, which talks to app config. Extensions, you can do it better. So app config has come out with an extension. What it basically does is runs an HTTP endpoint service within the execution environment, and that acts as a caching layer to talk back and forth from app config. So it basically synchronizes with app config, caches the stuff locally. Advantage is you don't have to have the SDK in your local file, and it's blindingly fast because you only, in your Lambda function, you're only making local HTTP calls. So that's a quick background. I then have this application, which I've got over here, and I can see this is my Lambda function, and basically it is going to pump out some, it's going to tell me whether it's a cold start, it's going to tell me a log level, and that's something we're going to pull from app config, and it's going to just tell me the event I'm sitting in. So super simple Lambda function, but what it's actually going to do is it's going to get the configuration from app config from literally port 2772 as a local service running the extension. So that's what it is. If I then build this with SAM, because obviously SAM is just too awesome not to use for anything, I have a SAM template which is built for a zip version of this application. And I'm going to make some really simple, I'm going to show you the simple changes I need to do to make it into an image repository, a container image format. So I can't use layers. I don't need to specify the runtime, and I don't need to specify the handler. So I literally remove these lines from my SAM template, and all I do is add package name to say an image, because I'm using a container image. And then all I add here is basically these two, this metadata to say I want to build from a Docker file and the location of my Docker file, which contains all the stuff and the where the application is going to run, is going to be built from within the source kind of thing. Now, when I was talking about that security bit later, this is the slightly funky bit that I'm going to use SAM build to be able to authenticate against S3 to be able to pull down the layer. If I look at the Docker file, this is all the stuff that uses the secret access keys. It's a horrible way to do it. We really, really don't recommend that you ever put your secret access keys anywhere. If you're going to use this kind of mechanism, really scope down your access keys, and be careful with your security. The blog post is actually going to be updated quite shortly, just to explain a bit more of this. But anyway, this is going to pull a layer, and it's going to stick it into a function. And here, this is in the CMD. This is where we're going to literally going to point to where our handler is. So if I run SAM build, this is going to build this function. Now, what I'm actually going to do is, I don't want to show you my secret access key because I'm playing a good security person over here. So as you can see, this is the command I would run, the parameter overrides. I'm sending the access key and the secret access key. But by the power of computing, I'm going to run over to another terminal window and use my real access key. And I'm going to basically build
magic.
And I'm basically going to go and do the SAM build. Then all I would do is I then do a SAM deploy with a guided. So let's clear that. I'm going to do SAM deploy. Guided, I've got a stack name, and this is going to wake up hopefully. Stack name, the region I'm in, the app config, that's just saying where I'm grabbing stuff from app config. The access key, I don't need this in here. You can see this is blank, and I would input the image repository where the container image format is going to do. And as you've seen there, I've got an error. Unfortunately, I haven't worked out yet because I was doing this lastminute.com. I haven't worked out what that error is, but to be honest, it doesn't matter.
But it's not related to the extensions either. Yeah,
it's just to the extension. It's just something funny that's going on. So basically what happens is this Lambda function is created, and we can see here it is built from a Docker image. Now, what I'm going to do is I'm just going to invoke that Lambda function. And as we saw before within the parameters, this is going to come back and say, that's the event that was sent. Is it a cold start? And the log level normal, which is now being actually grabbed from the app config extension. And that's a local call. I ran that again. And look, we are now no longer in cold start. So I can invoke this as many times as I like. And this is now a warm start for a Lambda function. But now, hang on, I've got an issue with my application. My log level is currently normal. I want to go and do something to make sure that my log level is verbose, for example. So all I do is I go into app config over here, and I create a new deployment. And basically, I'm going to say, you know what, why don't we change this log level to verbose, for example? And maybe my code would then do something else, or something exciting would happen. So I would literally just change that to verbose. So this is basically adding another version, hosted configuration version in app config. What I then do is I have that and I deploy that. So I am now going to deploy this out in my production environment. I'm going to do it all now because I want it to be deployed immediately. But this is where you would use the more advanced things of app config to say, well, I can do a canary deployment. I can run a whole bunch of tests. But that's beyond the realm of this. So remember back to my function. This is now going to be deploying. In fact, it's done. Look here. I'm now going to run my function. My cold start is false, so it's still a warm start, but my log level has been updated. Now,
so you just changed an AWS or a function configuration without rebuilding, redeploying. That's awesome.
So normally I would have had to update the environment variable for this function. Okay, that's not a problem. What happens if it is 100 functions or something like that? What happens if it's something where I want to grab something from my from a automated pipeline that maybe grabs a trace ID? I can go to X number of functions with app config and immediately update the logging level without having to redeploy the function on the next invocation. Even when it's a warm start, I've picked that up. So this function is built with a container image. I amended 5 or 6 lines to move it from a zip function to a container image, and that extension, the exact same files that were used in the extension are used in the container image, and it just works super slickly and super simply.
Very cool, dude. All right, it's me. Hey, look at that. It's me. I'm over here clearing things out. Okay. Hey, real quick, I want to address a couple of questions, a couple of statements that we had here. One was I saw an announcement for Service Catalog app registry that can group Lambdas into apps, Lambda functions. Are there plans to add SAM support for app registry or can it be accessed with CloudFormation now? So one of the things about SAM to understand is that if it is in CloudFormation now, you can do it in SAM. SAM is CloudFormation on steroids for serverless, is the way I describe it. So now, is there specific serverless-related functionality in relation to that? Not yet, but that's something that obviously may be built in a little later, but that's something to understand. SAM, ForceAware says SAM is great. I'd like to advocate for SAM CLI 2 for Glue and other service data services. Yeah, again, you can use those services. If I'm building a SAM application, I can have multiple Lambda functions using the serverless resources. I can then use standard CloudFormation resources as well. So, all right, app config. Well, we'll jump on that a little bit later. I'm going to do this demo, and I'm going to have one of the mods probably answer that for us. Let's jump over here. So what I'm going to do is I took Ben Smith, one of our awesome DAs out of London with Julian there. He wrote this application that demonstrates the new synchronous workflows or express workflows that you can do. So what that means with step functions is these express workflows, I can have synchronous in and out rather than having to pull for an answer later or sending an asynchronous request, something like that. So it's very cool. If you heard last week, Rob and I talked about possibility of starting to migrate APIs over to that instead of using direct to Lambda, we use synchronous workflows to write in, retries, to do more orchestration, things like that. Go back and watch that. But I wanted to demonstrate this for you real quick here. And I don't know why I'm clearing that, but there we go. So this folder name is really long. I probably should have made it shorter. But what I've done is I took this. There's a couple things we did here. First thing is, and you saw this with Julian's in how to make a function based on a container instead of let me go up here real quick. container instead of a zip file. So what I've done is I've converted his, and these three functions, I have three functions in here: notify admin with SES. I have generate reference number, and we've spelled reference, but that's okay. I'm going to fix that. And then detect sentiment. These are the three functions, and they all use package type image, and I pass this Docker tag, Docker context, and Docker file information as well. So it's really easy to kind of change those over, and now I'm using Docker. Now, if I wanted to, and I'll show really quick, I showed this last time, but just real quick, we'll jump in here. I could actually also, someone was asking, does SAM support this? So real quick, I'm going to build a Java app in SAM based on containers in about, it depends how fast I type, about 30 seconds. So let's go. So I'm going to say SAM init, and I'm going to say quick start templates. I'm going to use images, so 2, and then I'm going to go down and I'm going to choose Java 11 base. So I'll go 10 here, all righty, and I'm going to use Maven as my dependency manager, and I'll just call this Java app, and there you go. I just built it. That's a Java app based on containers, so I can CD into that. Let's go into my Java app, and I'm just going to do a little SAM build, and there you go. I just built that, and it's ready to be deployed. So there you go. Now it's just a hello world. So now I'd have to go in and edit the Java, which nobody wants to see me do that because whoa, I am not a Java person. But it's that quick. That's how fast SAM. So on a deploy here, I can literally, and in fact, we'll do it real quick. We'll start it, and then I'll come back to a little bit. So I can say, well, actually, I won't because I don't have my ECR set up. But I could do SAM deploy. I need to go create an ECR registry real quick, and then it would push it all up. Okay, and it's that quick, and I'm ready to go. So let's go back to the one where I'm doing the demonstration here, where we do the contact forms. So let me go back here. Any questions? Do it, Eric. I did do the Java. I could have done Go too. So all right, here we go. All right. So in here, what I'm going to do is, first of all, I've got this deployed already. So I've already got my repo out there. I've got my ECR repo, and I was able to deploy this application, and we're out there. Now, I want to show you something cool, and I actually didn't know this until yesterday. In my SAM config toml file, Alex Wood showed me this, who I posted yesterday. He's the person I go there. He's the person I go to when I need help with SAM. You can do more parameters in the config file, and you can do a build settings. So for my default profile, which everything's default unless you actually change it, I'm going to do default build. And anytime I do default.build.parameters, I want you to do the cache build and a parallel build. So rather than me having to pass -C, did you know this, Julian?
No.
Kaboom! There it is. All right, hang up. We're done. So,
and Alex Wood is no relation to me being Julian Wood, but I wish I was. So at least I could have some of his brain power in the family.
He is a smart guy. That is very, very true. So, all right. So now when I go in here, so normally I would have to do SAM build for Rob. I'll type it all out. --cache --parallel. I probably spelled this wrong. There it is. I could do that. Okay. And it built, built very fast. But what if I don't add these? Same thing, because I've got those in there. And you can see here that I've got cache versions of it. There we go. Using cache. There we go. All right. So I've just built that. Now, with SAM also, what if I want to test one of these locally? Okay, so this is where, I've created this new application, I've done some code, and I just want to try it. Does it work? One of my functions here actually calls out to AWS Comprehend or Amazon Comprehend. Oh boy, I'm going to get in trouble for that. And it's to comprehend, and it checks the sentiment of the text that we're passing in. All right, so here's what I'm going to do. I'm going to say SAM local invoke. And I'm going to say, because I have 3 functions, I need to tell it which function I'm going to do. And then I'm just going to pass an event to it. And I have these events already stored. If I can spell, there we go. Sentiment. Okay, now watch what happens. And we'll actually pipe this to JQ just so you can kind of see the formatted output. Okay, so I actually pull the container I need to test that. I just called comprehend. and I got back. And the text I passed in I'll show you that real quick. It was happy text. I said, this is lovely. And it's okay. That's positive text. Now I haven't, yes, I've already deployed this, but I don't have to deploy this to use these unless I need resources out there. If I'm testing something against Dynamo or something like that, then that needs to be out there. But I'm able to test locally and quickly see what happens. So let's go through to my event and let's change this. This is gross. Okay. So we'll see what that says. So if I go back to here, I can go and I can pull that same command. Okay. There we go. So now that's negative. Apparently that's not happy. All right. So I know we've deployed this. Now I want to actually test my existing one. And how this works is it's going to check the sentiment. It's going to create a ticket case, a ticket ID number, and then it's going to write that out to DynamoDB. And then it'll also send a notification via email to an admin. So let me see how that works. So I'm going to I have this curl. All right, there we go. And this is not a happy one, so I'm going to go ahead and hit this. And let's let me get that loaded up real quick here. All right, so there's my response. And you can see here's the message. I'm not happy with this service. The sentiment results that I got back. So this is piping right through the API. And then I have a ticket ID, and I'd have to dig it out in here. It's somewhere in here. But there's a ticket ID passed in here. Now, that's all being returned from the synchronous workflow via HTTP API. I'm using the new HTTP API, or Ben did, direct service integration, 2-step functions to trigger this synchronous workflow. Then that workflow is then calling my Lambda function. So I have orchestration going on. I'm not having to call one Lambda function and do a bunch of things, right? So a lot of my retry, a lot of my error handling is pushed off to the synchronous workflow. Rob's happy, everybody's happy, and that's how it works, all right? So let's see. I want to see if it actually worked. I did get the data back, but I want to check the logs on one of those Lambda functions because I want to see if it really is 1 millisecond billing. So let me take a look here. So I'm just going to say SAM logs, and then I can say the stack names. One is contact. You know what? I have this saved. I'm not going to type it all out here. Let me just arrow up a couple times. Okay, SAM. Oh, I should have just typed it, huh? There we go. All right, so here's my, no, it's the same local event. There we go. All right, here's my generate reference number. Here's my detect sentiment. So let's check this one. So I'm saying SAM logs, the stack name is contact form, and then the name of the function. Now, if I know that this is the logical name of the function in the SAM stack. If I know the actual name, the physical ID, I can just pass name without the stack. These are also contextual. You can set up in your SAM config file to tell which environment if you're doing it. So if I hit detect sentiment, and there you go. I show here that build duration was at 1,742 milliseconds because there we go. Wait for it. Build duration. Hang on a minute here. I had it. Let me clear the text is too big, so I can't read it. Let's try that again. All right, so we got that. There it goes. Request ID duration 756, but then init. So we had to add these together. Init duration, that's what threw me off. Init duration plus duration is 1742. So there you go, down to the millisecond. I was stumped for a second. I got a little nervous. Did you see that, Julian? Started sweating. But there it is. So, all righty.
Yes, it's just something to mention that with the container image format, you are billed for the init duration and the duration of the function. So that's like with custom runtimes, that's what happens. Container image work from a billing perspective the same as custom runtimes.
So, all right. There you go. And hopefully that makes sense. So we've demoed the 1 millisecond billing. We've demoed the container image support. We've demoed AWS SAM. We've demoed Express workflows. And we've demoed the HTTP API direct integrations.
Yeah.
Anything else?
That is awesome. Just to say one last thing there, that local testing, that's the really good way to think about the local testing. You're doing the local test of your function, but Eric in his example is talking to the cloud to do the sentiment analysis. My demo I could have also run locally, and that would then talk to, actually, that's interesting, the extension can run locally, but synchronize with app config up in the cloud. So yeah, this is a great way that you don't bring the cloud to your testing and try and mock everything. Just test your function and connect to the service integrations up in the cloud.
Man, I can't agree with you more. And I'll say it again. Yeah, bring the developer to the cloud, not cloud to developer. We all talk about that. I have been down the road of emulating local services, and I spend half the time trying to figure out, is it just my Docker configuration? I can't do Docker network to save my life. That's the truth. Yeah. So yes, we are set up to be able to test cloud services. Really, the only local service you should be testing, or that I test, I'll just put it that way, is a Lambda service, because that's what we're iterating on the most. You don't want to have to deploy it every time. So I make changes. And if that would have been HTTP API to a Lambda function, I can also use start local API. Which would allow me to hit that as an API too. So,
yeah.
All right.
Yeah, just quickly, let's spend the last few minutes just looking ahead at reInvent. There's a huge big track at reInvent for serverless as well. Use this QR code. This is serverlessland.com. This is literally the site our whole team maintains. We've got a ton of content there, from video series to blog posts to links off to blog posts to all of this. And there's a whole page on the top left you can see for reInvent. And this is a really good way to find out all the times and the content of all the sessions that are running at reInvent. Looking quickly ahead, the week one sessions, each week sessions get released for on-demand viewing on a Friday.
You said pay-per-view. That's awesome.
On-demand viewing on a Friday. So last week's ones, this is the serverless track ones, really good sessions. These are the builder sessions as well. So these are our brightest principal engineers who are putting their crazy big noggin brains into these sessions to tell you literally how we run AWS services. And then
you notice Julian and I were not listed on the big brain list.
No.
Yeah. And apparently, because you get a pay-per-view, you get this from 1980 cable company. So.
Exactly. So this is week 2. This is on at the moment. All of these things are going to be available. You don't have to pay-per-view it from tomorrow. Some great things to call out. Ajay Nair's building revolutionary serverless applications. That's the bigger picture, looking at why we're releasing all these kind of things. Ben from our team, if you're doing PHP on Lambda or thinking about doing great kind of thing. Rob Sutt has just done his first iteration of that, securing your serverless applications.
Security master.
Awesome to look at.
Yeah.
And then week 3 starts all of next week. So just when you've caught your breath and you spent your whole Friday and your whole Monday watching reInvent videos, there's another week to go. And I'm super excited about this. And I know Eric's super excited about this.
I am. There's 3 really smart people here and 2 other ones. So you enjoy that. In all honesty, so some really, really cool stuff coming out. Chris Munz's optimizing your service application, always good. Has a lot of nuggets in there to come away with. David Richardson, as we talked about earlier, big brain. Marcia, if you don't follow Marcia, she's serverless advocate. She does a wonderful job. Julian and myself. Julian, I will tell you, the observability. Huge thing on serverless is a lot of people forget the huge thing anywhere. They forget the observability. It's an afterthought. And Julian really talks about building that in, and then of course API gateway beyond the proxy. And I want to actually, and I know we're close on time, but I want to go back to that. There were some questions earlier on what do you think? I think someone was asking James, what do you think about calling or invoking Lambdas directly with an SDK rather than worrying about HTTP API or worrying about APIs? That's always possible, and I've done that route. But that's some complexity. That could be some complexity, and there's some security things you want to make sure of there. With API Gateway, you may not be using all the functionality of it, but I would look at least an HTTP API proxy. We built HTTP API to be much less expensive and much faster. And what you'll find out is now I can, rather than me having to know in my app, okay, where's the SDK? I got to sign these calls. I got to handle all that. You can use the JWT authorizer. You can use an IAM authorizer. You can use a Lambda authorizer. You can throttle. You can, you get into, so you realize, hey, maybe I should be using some of these functionalities. If that's even too much, then look at using an ALB in front of a Lambda function as well.
Or even, I mean, think about it from another level as well, is if you don't want or have the need to run the API, and there's a whole bunch of functionality, is you can use CloudWatch events. So you can literally, if you've got a Lambda function that fires once every hour, once every day to do some compliance report, or copy a file from ASB or whatever, that kind of thing, use a CloudWatch event. Use the integrations for Lambda that are there. 140 plus integrations with Lambda. Upload a file to S3. Add a record to DynamoDB, automatically triggers off a Lambda function. So you don't often need to manage the triggering of a Lambda function yourself. All these service integrations do it for you. Yes, you can use the SDK, you can use the CLI to do that, but maybe just run it as a scheduled task. And it's so easy now to run an API. It's super cheap with HTTP APIs as well.
What was that word? Schedule? Oh, man, I don't sound right saying that. I sound dumb. Schedule. Here in America, that's schedule. Schedule. That's awesome. Yeah, schedule. I like that. So, all right. Well, any others coming up?
Yeah, this is just the second part of week 3. James Bezic, awesome with EventBridge, and Mark Ricker as well. He's one of our principal engineers, and that's all talking about how Lambda functions are isolated from a security perspective. He's a super brain to be talking about that.
Big brain.
Yep. And then next week, it will be our last Twitch one. So, yeah, we're getting to the end of reInvent.
Yeah. And I think that's Rob's going to be on there. I'm not sure who's with Rob, but Rob's going to be on there, and always entertaining, always good stuff. So with that, we're at time.
We are. It's going quickly.
Wow. Yeah, we hit it. So hey, really, we just want to do a call out and say thank you for all who are watching. Thank you for who are building serverless. I'm an advocate of serverless for everyone. If we can be of help in any way, hit us up. These are our Twitter handles right here on the screen, plus the DA team. We're glad to reach out, and you're welcome for the great demos. And we're glad to do anything else. So check out serverlessland.com. There's another way to see what we already have out there. This particular episode will be up there pretty soon. But with that, I'm signing off. Julian, I'll give it to you.
Oh, thank you so much. We super appreciate you spending your time with us here today. Please, any questions, any bigger things? We know the container image format has got a lot of nuance to it. Please ask myself or Eric or anyone in the team for questions about that or anything else with serverless. We're here to help. If you've got product or feature ideas or things like that, get in touch with us. We've got the direct hotline to some of the best organizing brains within AWS. So we'd be more than happy to send your feedback. And yeah, thanks for spending our time today. Enjoy the rest of reInvent, and yeah, we'll see you soon.
Stay safe.